The overview of the project. Before I start any project, I do like to do a general flowchart, if you will, and this should be done anyway, regardless of how simple it is or whatever you're doing. This gives you a very brief overview, a top level overview of what you plan to do and to keep track of it and to have an actual plan. As I said before, fail to plan, plan to fail. So before we get into the main schematic, I'll just like to go over this. So we got the power, we go to 3.7 volts. So this is nominal. They go to maximum 4.2. Micro USB, no need for larger charging power. Apparently I cannot speak English, even though it's the only language I speak. But you get it. Okay, so the micro USB can deliver a max of 500 milliamps roughly. I don't need a large one because it's such a small battery anyway. So 4.2 as I listed down here goes to this battery charger because I don't need a protection circuit, because usually with these LiPo batteries they do have a protection circuitry on it. You do have to check though, because some of them I could imagine they don't come with it and you need to implement your own, but the ones I got they do. So goes to a battery charger, which I've put, there's a hyperlink there. Go to a buck boost converter because our battery voltage is dipping and it can go past 3.3. I believe the cutoff might be 2.5 volts for these types of batteries, 2.6 or so, and because of that we need something to boost it back up again. So at 1.7 amps, don't think we're going to use that. We're going to use very little actually, but the efficiency is quite good. Taking that up, sorry, to 5 volts, we're bringing this to the MQ2 sensor. Now this is because it does require 5 volts to run off. This is the only component in our circuit that requires is 5 volts. The rest for stepping down through just a simple LDO, 3.3 volts to the microcontroller and into our peripherals over here. You can see I've listed a bit of notes on what I'm doing, and peripherals, LEDs, and as well the 10,000 ppm equals 1%, as well what I imagine for the lights here, because I'm using LEDs. Moving on to the more important part, the main focus. So this is the main overview page. I'm still getting used to KiCad, so I would like to know a way if there's you could probably make a much nicer title page or table of contents, if you will, to know what people are looking at. So we're going to be moving from power first. We got the charging circuit, micro USB, IC charging, so LED indicator to show when we've got a standard. So this is a P channel FET, and what this will do is that when VUSB has been detected, so when a user does plug it in, P channel FET is normally conducting, so it's normally open. This allows current to pass through, and upon applying voltage to the gate, it closes the FET. So this will just leave this battery charging, and we will have the USB going through with whatever it is. I do not through this Schottky diodes. So I use Schottky diodes because they have a very low forward voltage in comparison to standard diodes. Of course, I might need to reiterate this, but it should be alright. This is very standard. It's very standard circuit. So this goes through our power switch here, and you notice I've used a rectangle instead of the actual switch, but unless I would put the standard switch symbol. So I've put this as VDD because this voltage does vary between 5 volts and whatever because of UV USB. Well, coming into our boost converter here, VDD, it's taking 5 volts to 5 volts, so it's not going to be any different really. And going to step down 3v3 VBAT feedback. VBAT feedback is just there for it to read our battery, so we know, because we do have an RGB LED for as our battery indicator. Onto the micro portion, I'm not going to cover this all, this was covered in the previous video. No microcontroller, just your JTAG, simple power supply, reference schematic, and just all the pins connected up, and your crystal. Nothing else too fancy going on here. So we'll briefly go over that. Our very lonely MQ2 sensor. So the way this works is it does have 6 pins in a more like a hexagon shape. That's 6 points, and needs a load resistor. Goes it analog out, I believe. So what it does is it heats up the filament. So there's actually 2 heaters to this portion. That's why there's 2 supply voltages. One is to heat up the filament and one is to actually take the reading, I believe. So you can search this up. It's an interesting thing. You can actually open up. They only cost about £5 roughly. It's interesting what's inside. It's like a little paste almost. It's very crumbly paste, and it's right in between some thin wires, and they heat that up when, I'm guessing, the gas gets detected on, and after a while it just it stops bonding to the some fancy chemistry stuff. I'm not a chemist. And our last page is the peripherals, just some LEDs as we've been speaking, as we've spoken about before. LEDs, RGB, and buttons. So the buttons are here for the user to, of course, I want to have this on a time period of, let's say, like a wake up, like every, I don't know, 5 minutes, a wake period of every 5 minutes or so. But the user can then press the button if they want to read it faster or whatever. It's a bit redundant for the gas one, but the battery one, I would like the user to press it. Maybe I will have it shown if the user does place this in a very hard to reach area, but we'll see. Button is just there anyway. We also have the reset pin here. And that's it. There really wasn't much to this project. The majority of it was probably in the power schematic, and it was very simple. I wanted to keep it simple, nice and easy, and again, this was for learning and to get a feel for it as to what we can do. The next step from here is to check out the footprints, make sure they all match up, and it's not a very fun process, but it's a process that needs to be done because I have not checked any of these before. But once they are checked, then I can reuse them if I know they work and they match and so on. Just needs to be done, because what would be worse if you get the board and it's a wrong footprint and you can't build it at all. Better to do it now. And then once after that's complete, we can finally get on to layout.